You've probably seen some of these LCD displays. The most common one here is a 16 by 2 character display. You can get them pre-packaged with a couple of buttons and install them on the Raspberry Pi. So I'm going to show you how to make the connections yourself. So you've got your own Raspberry Pi, one of these LCDs from pretty much eBay, wherever you want. But what I'm going to do today, I'm going to put one together, a slightly larger one. This one's 16 by 2 characters and this one's 20 by 4. So what I'm going to do is I'm going to solder these on here so I can plug cables in and out pretty easily, and I've already put them on another Raspberry Pi here, so I'll be able to just plug them straight in. So I'll go through how that's done now. Now I could put them on this side so it's easy to get to, but what I'm going to do is I'm going to go from the back here. That way there won't be much sticking out the front if I want to ever mount this to some sort of device in future. I'll just be able to plug them in from the back. I'll do that now. So do the end too, just to hold it roughly in place, and then check it's all good, and then just do the rest. Now not all of these pins are needed, but solder them in anyway to give it some structural strength. Okay, there we are. So now I've got the terminals soldered in. Now most of these are just a piece of wire connecting one of the GPIO pins to the LCD, but one of them will have a resistor in it. Now that's for the contrast. So just point that out here. Okay, normally you'd put a variable resistor in there and you can adjust the angle of viewing on that. So if you don't have a resistor, or you have just shorted out straight through piece of wire, it'll either be completely white or completely black. You won't be able to see any text. So the value I found here was 330 ohms, seemed to be a good one. So I just hard soldered a 330 ohm resistor in. But you might want to check around on your display. If not, try 330 ohms, it seems to be a good one. And the other wiring, it seems a bit all over the place, but what I did, I just pretty much copied what these were, how these were wired, so that in the software I didn't have to make any changes between the pre-manufactured one and the ones I put together myself. I'll just go through these pinouts and what they mean. The first two, VSS and VDD, that's where your power goes in. So VSS is ground and VDD is 5 volts. The next one, VO, that's to do with the contrast. That's the one that I said before has the resistor in it, and depending on the value of that resistor, changes the contrast of the screen. So register select is what RS is. That's so when you're writing data to it selects the register. Read write is the next one, but we're going to tie that to ground because we're always going to be doing write. We're never going to be reading from this. And E is for enable, again for when you're writing to this to set the message. The next 8 pins are the data pins, but we don't use the first 4 of them. We only use the second 4, so from D4, D5, D6 and D7. And the last 2, the anode and the cathode, that's for the LCD backlight of the display. Now you can either tie that to constant power, or we can put the anode to a pin where we can then toggle it in the program so we can make it flash if you want. Here's a little snippet from the program where I show where you initialize the display, and you can see you're assigning those pinouts to what GPIO pins you plan on using. And these are the ones that get that pre-manufactured board working, which is why I just followed that when I do my wiring. You can actually have more than one of these displays on the Raspberry Pi. You just set up a different instance of the LCD display. But I'm only going to use one here, and you can see that LCD backlight down the bottom, pin 25, that's the anode to the backlight on the display I just mentioned. Okay, so there's the end, roughly kind of connected. And you know, maybe in the future I'll stick that back on there and do something with it, we'll see. Now where I said you needed that resistor for the contrast, what I'm going to do, let's put the others back in. I'm going to put an extra jumper cable on, just for now, and just put the resistor in line. Okay, so I'll link that up a bit later, for now I'll just leave that there. So I'll power this up and install the software and see if we can get a message on there. First thing we've got to do is grab the Adafruit Python character LCD library for it, and once that's done, just CD into that directory and install it. Pretty simple. Python setup pipe install. Once that's done, you can then write programs using that character LCD, and now the Raspberry Pi will know what that is. Now this whole thing is dependent on the SPI interface being active, so make sure you do enable that, otherwise it won't work. Okay, now that's installed, you've got to go to the Raspberry Pi config as well, and make sure that under interfacing options you have SPI enabled, otherwise it won't work. This is that example program. The only reason I've imported time is for the sleep down here, but basically what you've got to do is import that Adafruit character LCD as LCD and define the pinouts. Now this is where we decided which GPIO pins we were going to use. You can use whichever pins you want as long as you define them right here. As I said, I picked these because they were in that hardware device that I previously had, so I just went with the same pinouts. LCD columns and rows, pretty self-explanatory. It'd be 16 by 2 for the little ones and 20 by 4 for that big one. Now, here's your instance of that LCD where it just assigns the variables you set above here. Now, you can, as I said, have a second one, and you would assign the variables that you define for it on different GPIO pins. So if you've got enough GPIO pins spare, you can put another however many you want on there. Just in this case, there's only one that's called LCD. And then to put a message, it's LCD message. And I just put, yeah, your mama goes all right, with /n being the standard new line character. And down here, I've just got it to flash the backlight on and off, just to show that it works really. But that's a very simple program that displays a message on the screen. And there's more information about that on that Adafruit character LCD download page. They go through the instructions there. Now once that's done, as you can see, I've got 4 lines of output. And here's what happens if you don't have a resistor in. You don't get any contrast and you can't see the message. It is actually on the screen, but until you get a resistor. And this resistor value is 2.2K. That's what it worked out for this one to be nice and visible. But of course you can put a variable 1 in and just always change it. And the reason we put the anode of the LED backlight onto a GPIO pin and not just solid power was so you can have the option of turning it on or off. Now that I know what value resistor I'm going to use, what I'll do is I'll neaten up this cable and solder that in between the cable run there and put some heat shrink over it. Now that cable that I just took out, I'll just run that with the others and got a bit of an idea of how much to take out of it, which is where I'm going to solder this resistor to with the heat shrink over it. So just see how much of the space over the legs that will take. And most of it. I can trim a little bit of this off. So once it's soldered, it should fit nicely. Okay. Put the heat shrink over, ready to go. Okay, just okay. Just a bit of solder on that. Now for the resistor, same thing, just get it ready. These are old resistors I just had in a pile. Still go right. Bit of solder on there. Okay, that end's done. Bit of solder. Okay. So once that's on, I'm going to have the cable with the resistor in the path and the heat shrink over it, ready to go. And of course I don't have a heat gun. Okay. So I can still see the, oh that's caught a bit, still see the value of the resistor. Okay, so now, plug that back in. Right, that's pretty much done. And of course with the Raspberry Pi you can, especially a little wireless one, you can make some device and put it somewhere and have a nice little package like that. So here's the end product, the 4-line version flashing away. Very similar to the 2-line display, same programming and all that. And here they are side by side.